But these, with no radicals and no i's, I want you to just be able to go straight to mentally FOIL that binomial times itself into the first term squared plus, right? AB doubled, 4 times x doubled, 4x, 4x doubled is 8x, and then plus, always plus 16. All right. X minus 3 squared. Okay. You just want to be able to do this in your sleep at this point. Yeah. X squared
6x.
minus 6x, good. 3x minus, and then 3x doubled, and then always plus for the last one, 9, because it's either 2 pluses or 2 minuses, so the last one's always positive. Okay. Okay. Now, the patterns we talked about are that you've got, this is, what you basically have here is ax squared plus or minus, I'll just use plus for general, but ax squared plus or minus a bx plus c, right? And because it came from a binomial squared and therefore makes a perfect square trinomial, that means that your first term and your last term are perfect squares, right? Perfect square, perfect square, perfect square, perfect square. Okay. So this is our general quadratic form, but this is specifically because it's a perfect square trinomial. It means our a squared, our first term is a perfect square and our last term is a perfect square. And our middle term is just that whatever this, the a, this unsquared doubled. Okay. So we know that to get that middle term, we did this times this doubled. What is the opposite of doubling? Dividing by 2, right? So just like we can go in both directions, this times this doubled gives us this. This cut in half gives us, Now, if I cut this in half, instead of doubling, I cut it in half, 6 divided by 2 equals 3. Now square that. You get a 9. Because if I unsquare this and then double it, I get 6. Unsquare this to get 3, double it, I get 6. And I can do that because in this case my a equals 1. Okay? So if I unsquare this and double it, I get 6. If I unsquare this, what do I get? 4. Double it and I get, well, the opposite of unsquaring is squaring, and the opposite of doubling is dividing by 2. So I can also go in the opposite direction. If I take this and divide it by 2, break it in half, I get 4. And if I square that, I get 16. Okay? So that's an opposite relationship there. The opposite of doubling is dividing by 2. The opposite of unsquaring is squaring. So if I have a trinomial of my basic ABC trinomial, and I want to know if it's and I know it's a perfect square trinomial, then it's going to have this relationship. My C, my constant, is going to be equal to my linear term, my linear coefficient, broken in half and squared. If I take my linear term and I break it in half, undouble it, and then square it, the opposite of unsquaring, then I get this number. Okay? This is the same thing as this broken in half, 3 squared. This broken in half, b divided by 2, is 4, squared is my number there. Okay? This is a really important little relationship. Because you know if you have just a general trinomial, that's another way to test a perfect square trinomial. Is your constant half of your linear coefficient squared? Okay. Now, knowing that relationship means we can create perfect square trinomials. If we have an x squared and a b, so if we have a quadratic and a linear term, we can know exactly what c we should have in order for it to be a perfect square trinomial. So if you have the 2 variable terms, you can create a magic c that creates a perfect square trinomial, as long as your c is half of your b term squared. So, let's say we've got x squared plus 4x is equal to negative 3. Now, to use our square root property, we cannot have a linear term. We have to have just a quadratic and a constant. Do we have a linear term here? Yeah. Right. So we cannot just, if you just try and square root both sides, illegal move. Okay? In order to use the square root property, you have to have no linear term, only a quadratic and a constant. But remember, the other form of our square root property is not just x squared equals c, but it's also binomial squared equals c. So if we have just a number on the right but a binomial squared on the left, that's good too. Oh, maybe we can make a binomial squared, and then we can use this property. Well, we can make a binomial squared if we have a perfect square trinomial. Now, if I added 3 to both sides, okay, so I'm just going to do if I did x squared plus 4x, if I put it in standard form, plus 3 equals 0. Is this a perfect square trinomial? No. So I can't just make it. That 3 is not going to help me. Okay? I want to make a perfect square trinomial, but that constant's not working for me. Sure, I can use the 2 variable terms, but I'm going to need a brand new magic constant. Can I decide what constant to use? I have a b.
Not just use that.
Yeah. Not use this one? Well, if I use that one, it's not a perfect square trinomial. I need a magic c that is going to make these 2 variable terms, I need a new c that will make this into a perfect square trinomial. And my c, if I have a b, I can divide that b by 2 and then square it, and I'll have my magic c. Because it'll have that right relationship. My b and c will have that good relationship that will make a perfect square trinomial. So, now if I did put this in standard form, this one's actually factorable. Okay? So, and this would actually be the easiest way to solve this one. I'm just using this as an example of how to complete the square, because you can use completing the square for anything, whether it's factorable or not. Okay? In the end, factoring would be the better choice, the easier choice for this, but this is going to be a good example for how to complete the square. It's going to work for anything. Okay? So completing the square, all completing the square means is I'm going to create a perfect square trinomial. I have a linear term, so I can't just square root both sides. Okay? So that 3 is not going to work for me. Even if I move it over here to the left, still not a perfect square trinomial, not going to work for me. So I want to leave it over here on the right. Okay? But I need a new constant. So I'm going to write x squared plus 4x. I want my linear terms on the left. And I need to create a magic c, a new constant that is going to make this a perfect square trinomial. Now this is equal to negative 3, but I also need to write plus blank over here. Because if I add something over here, that's fine as long as I add something over here. I have to keep the scale balanced. Okay? And I always write in a plus blank on both sides to remind myself, keep that scale balanced. Otherwise, I'll add a new magic c over here, and I'll forget to add it over here, and then I'm wrong. Okay? So I'm not going to change the value of this. I'm just going to add a constant here that will magically create a perfect square trinomial, and then as long as I can add it over here, keep it balanced, I'm going to be able to move forward. So I need that magic c. And so my magic c, that's not going to help me. So my magic c, this constant that will make this a perfect square trinomial, as long as my c is half of my b squared, then I'm good. So what's my b? 4. Break it in half and square it. And so my c should be 2 squared, which is 4. So I'll add 4 there. And this helps me remember, as long as I've got to keep the scale balanced. Then now it's fair. I haven't changed the value of anything. But what I have done is taken, what was a trinomial that was not a perfect square, and I created a perfect square trinomial. And then I've got just some numbers left over here, numbers that didn't work for me. Now, I don't have to test if this is a perfect square trinomial. A is x and b is 2, and then 2x doubled is 4x, check. Like when I was doing factoring, I had to check if it was a perfect square trinomial. I don't have to check that because I know it is, because I just made it. Okay? So I know I immediately can factor it into a binomial squared. And remember, your binomial squared is just your a and your b, your first term and your last term unsquared. Okay? Now, a is 1, so I'm going to have a naked x. And is it going to be plus or minus? Plus. And then, so I'm just unsquaring them both. So what goes here? 2. And that's equal to 1. And you know what to do with that now, right? Square root property. And it would have been factorable, like I said, but. So it's negative 2 minus 1, which is negative 3, or negative 2 plus 1, which is negative 1. Okay. So, we have time for, let me give the basic rules for when you use completing the square. And we'll do one more example. That'll get you started. Now, there's other methods for, you don't have to use completing the square. There's another method if you ever used the quadratic formula before, if you read ahead. You can just use that for everything. Keep in mind that completing the square is a very important skill that I want you to practice now, even if you feel like, oh, I don't have to use it. I can just use this other method. If you don't practice it, 1, you won't be ready for other times when you have to use it, moving forward into college algebra. And 2, you have to show me on the exam that you can do it. Okay? So practice it in homework. Don't avoid it in homework. Look at the directions for all the problems in the homework. If it says complete the square, complete the square. I only included ones for completing the square where it's the best possible time to use it. Okay? I didn't include really crazy ones for that. Okay? Because there's a best time to use it and not. Okay? So for completing the square, okay? So use this when, okay? Well, here's the thing. You can use it for any quadratic. Okay? You can't. Huh? This, no, this is the third method. Yeah. So you can use completing the square for any quadratic. But that doesn't mean it's always the best method to use. Okay? It'll work for anything. It'll work for any quadratic, ax squared plus bx plus c. Meaning you have a quadratic, a linear, and a constant. So remember, for doing the square root property, you couldn't have a linear term. Just a quadratic and a constant. Completing the square will work for any quadratic that has your a, b, and c, that has a quadratic, linear, and a constant. It'll work for any of them. Okay. However, it's best if you have these qualities. Okay? If you have x squared plus bx plus c, in other words, a is equal to 1. If a is not equal to 1, then you would have to divide it away. And then you end up a lot of times with fractions. Okay, we'll do an example like that on Tuesday, because fractions aren't that scary to deal with. But if you're choosing a method, it's best if a equal 1, so you avoid fractions. The other way to avoid fractions is if you have b is even. Because remember, our c is just b divided by 2. So if b is an odd number, then when you divide it by 2, even when you square it, you're going to have a fraction. Your magic c will be a fraction. And so it's best if you can avoid fractions, and the way to avoid fractions, if your a is equal to 1, because otherwise you have to divide it away, and that can create fractions. And also if your b is even, because when you find your magic c, you have to break it in half, and if b is even, then you won't have fractions. So you can use it for anything that has the quadratic, linear, and constant. But it's best if you use it with a equal 1 with an even b. Okay? So I'm going to give you ones and tell you complete the square on these, and they will have these qualities. But moving forward in the future, when you're deciding, oh, which method do I use, that's how you want to determine if it's the best method. Okay? Now, another thing to realize about completing the square is you must put it in this form. Okay? So make sure it is in, this is the setup. Okay? The setup or the form. Okay? So the setup looks like this. You must have your x squared and your bx on the left equal to a number, and I'm just going to call it, I'll call it C now, but you're going to find a new magic C, okay? But when you're first given the problem, it's not, again, this is not standard form, right? Square root property and completing the square do not use standard form. Okay? Square root property requires a quadratic equal to the number or the binomial squared equal to the number. Completing the square requires that your variable terms on the left, both variable terms, because you also have not only a quadratic but a linear, so your variable terms on the left and your constant on the right. Constant still on the right, but instead of just a quadratic on the left, you have a quadratic and a linear. Okay? So variable terms on the left, constant on the right. That's your setup. You cannot start completing the square until you have that. Okay. Make sense? Okay, so let's walk through one more. That'll give you enough to get started with. Okay. So let's do x squared minus 20x plus 30 equals 0. Now, I would tell you to complete the square on this, but also understand that because it has a quadratic, linear, and constant, you can complete the square regardless of whether it's a good idea or not. And also, is a equal to 1? Yeah. I have a naked x squared. If your quadratic term is naked, a equals 1. Okay? Good. And is your b an even number? Yeah. So, not only can you complete the square on it because it's a trinomial, but it's a good one to complete the square on. Okay? So, you're ready to complete the square once you set it up in the proper way. You don't want it, it's in standard form right now, you don't want it in standard form. The first one I gave you was already in the proper setup. This one, you have to set it up first. Because using this method requires this setup, not standard form. So x squared minus 20x equals negative 30. Now, with just your variables on the left, you are going to create, because that constant, this was not a perfect square trinomial. That's not a perfect square. Not a perfect square trinomial. So you're saying, okay, thanks 30, but you're no good to me. Go outside. I need a new constant that's going to make a perfect square trinomial. I don't have one now. Push the 30 out the door, quite rude, and invite someone new. Someone that's going to help you. Based on this 20, you're going to be able to find a new constant that will give you a perfect square trinomial. Okay? So first you push the 30 out of the way because he's doing you no good. Then I'm going to go ahead and just rewrite that with my plus something, because I'm going to find a new magic C that's going to help me. And I've got my negative 30 over here. I'm going to go ahead and write a plus blank there, because otherwise I know I forget to add to both sides. That's the most common mistake I see in students too. Okay? Now you got to find what that magic number is. And remember, your new magic C has this relationship. Okay. So based on an a, just a plain old naked x squared and a b of 20, and don't worry about this being negative 20, because once you square it, it's going to be positive anyway. Remember, your C is always positive in a perfect square trinomial. So you can put negative 20 here, but it doesn't really matter. It's going to square away to a positive anyway. Okay? So your b is 20, or negative 20, squared. Either way, that's 10, or negative 10. Either way, if they're in parentheses and they're squared, what is your C? 100. Okay? So by putting a 100 there, boom, you created a perfect square trinomial. Okay? Because this unsquared is 10x doubled is 20x. Okay? Don't forget to add it to the other side. Keep the scale balanced. So you know you have a binomial squared. Because a equals 1, it's going to be a naked x, and it's going to be plus or minus. So your binomial squared, your factored form is x minus 10 is equal to 7. Now you can use your square root property. Simplify that if you can. 70 can't be. Okay. But you'd have to try. Okay. So x minus 10 is equal to plus or minus radical 70. Simplify that if you could. So x equals plus 10 plus or minus, positive 10 plus or minus radical 70. Questions? Okay. That just takes practice. I will scan these notes in, of course, the videos before I leave today. I'll be down in the lab in 10 minutes. And it's the first half of the homework. Once you see the directions say use the quadratic formula, you can stop there. That's what we're doing on Tuesday. That's our fourth method. Okay? So the first half of the homework is using the square root property and then completing the square. As long as the directions say that, go as far as you can. And the second half we'll do Tuesday.